Hello, everybody, and welcome to episode 27 of the Hot Path Show. I'm Johnny, and today just doing a little solo episode. And this is like the first time I've talked today. My voice is already a little bit raspy. So, anyways, welcome in everybody to the Hot Path Show here today. Going to be a fun episode here today because we're going to be announcing the winners of the Turbo Mace Games Game Jam. So you may remember a couple weeks ago, hosted a little bit of a game jam. The theme of the game jam was stuck in a simulation, and we had a total of 13 entries. And a few weeks ago, I played all the entries on the stream, and there was like a big voting period available for everybody. And yeah, in today's episode, we're going to be announcing the winners of the jam. And I'm thinking also it would be a cool little idea for kind of like the main portion of the show to just kind of like dive into the code a little bit on some of the winning submissions. If there's anything that anyone kind of in particular has wants to see, feel free to leave it in the comments, and we can kind of dive into some things and just kind of see how things are all working here. So yeah, anyways, let's see, how should I go ahead and start this off here? Let's just gonna go ahead. I don't really have a whole lot in terms of like announcements or anything this week. Not a whole lot of crazy things going on. Do just want to remind you that you still can get tickets to Unite. However, you've now officially missed out on early bird pricing. So it's only the regular pricing from here on out. But yeah. Let me see. Do I have anything else that I want to bring up? No, I guess we can just kind of start getting into some kind of interesting topics here. Before I get into the winners of the game jam and everything like that, do just want to have a little bit of a quick tip for you all. I mean, this is just kind of some random little fact that wasn't something that I necessarily thought about, but ended up kind of working out in the end. So let me go ahead and share my screen here. So we can do this and this and this. Okay, so yeah, what I wanted to share is actually got asked to participate in, I'm sure many of you are familiar with the channel Blackthorn Prod. They do a bunch of kind of like collaboration type videos. They're kind of like big thing is like, 5 game developers made a game without communicating. Anyways, I did one with them last year. I'm good friends with those guys. I've met them at a bunch of the conferences. They're good people and everything like that. And so they recently asked me to participate in the 100 devs version of it. So I believe I was dev number 75. Excuse me. So I'm going to be basically closing out episode 3 because they have 2 episodes already out there. The first 25 devs 26 through 50. And then I believe this Sunday they're trying to have the video out for devs 51 through 75. So I was closing it out here. And yeah, so we got this little project. I'm not going to completely say what I did in the project yet until the video's out and everything. But of course, I wanted to add a little bit of ECS chaos into the mix because why not? So yeah, loaded up this project, installed all the dots packages and everything like that, and then started actually like setting things up. And I'm like, wait, why aren't my entities rendering? What the heck is going on with that? Oh, this project is still using the built-in render pipeline, which of course is not compatible with Entity's graphics. You have to be using URP or HDRP, of course. So I'm like, well, that kind of screws up my plans a little bit here. So it actually, though, ended up working out because a lot of the enemies and like kind of items and stuff in the game, they're kind of in this like little like kind of Paper Mario type style where it's really like 2D graphics that are just kind of like floating out here in space, right? And they kind of like, billboard to face the player so that you kind of get that like little bit of a 3D effect. Yeah, as far as how much time all the devs have, I don't know if there was really like a set time. They basically just gave it to me kind of at the beginning of the week and said, hey, you have until this day because we're trying to go live on Sunday. So I didn't really have a whole lot of time to do a lot of stuff with it, but I think this stuff that I did ended up being pretty cool. But anyways, what I wanted to say is still did end up using entities in here because if we go to the entity spawner and we take a look at this little gnome entity, actually I'll probably have to open up the prefab for this. So the renderer is just a sprite renderer. So I'm not using any like, game object synchronization or anything like that. So yeah, it still renders things with the sprite renderer. And it was really interesting because I, set everything up and I'm like, oh, well, Entities Graphics isn't going to work with the built-in render pipeline. So I'm like, you know what, let me just uninstall the Entities Graphics package. And I did, and then now the sprite renderers weren't rendering. So it's kind of like in a weird state where like basically it renders the entities with the sprite renderer, but you still need the Entities Graphics package, but the Entities Graphics package can't render 3D things with the built-in render pipeline. So yeah, just kind of like a little bit of a weird edge case that I had to navigate around, but ended up working out in the end. So I did just want to kind of call that out for the quick tip of the week because I thought it was kind of funny. So yeah, once again, look forward to seeing the video this coming Sunday. I actually hadn't watched any of the previous videos in this challenge. I kind of had like a feeling that I might get tapped on at some point to get invited to this challenge. So, really went into this completely blind, had no idea what was going on. And it was definitely interesting figuring out how to integrate with some of the like existing pieces of the project, just because there was absolutely no communication. There's no, coding standards or everything like that. Everyone is doing their own different way of doing things. And yeah, let's just say there are a bunch of things that were kind of done one way that I certainly would not have done that way. And yeah, it was just interesting trying to get to piece everything together to fit my portion into this project in the way that I wanted to. I ended up having to do a little bit of hacks and workarounds and stuff, but yeah, overall it was fun. And yeah, maybe I'll talk a little bit about kind of the stuff I did on a future episode here. Okay, so with that, gosh, do I have anything else to say, or do we just want to get into the main topic of announcing the winners of the Game Jam? So who's excited to hear about the winners of the Game Jam here? I'm going to be announcing the top 5, and then after that, I will make the full results public so you can kind of go through them yourself and see yeah, how everyone scored. So yeah, it looks like we got some excitement here. Looking forward to seeing all the winners here. So let's go ahead and pull up this here. That is true. Lots of Unity is hacks and workarounds. Okay, so I'm going to do this one tab at a time here, so hopefully we don't spoil the upcoming winners or anything like that here. Okay, well, here is number 5 here. We have Majo's PC. This was submitted by Hassanish. So let me pull up the scoring and everything here. So yeah, this got number 5 in the overall category with an overall score of 3.446. Basically, I think the way that this works is we had 4 categories of voting. So theme, gameplay, aesthetics, and usage of dots. And so basically, I think it like takes your score in each of those categories, averages them out, and then you get the overall score. So yeah, this is Majo's PC here. Again, I played these all on stream a couple weeks back, so if you want to see me playing through them, check that video out. So basically, this is kind of like a Survivors type game, which I think is great for kind of like a Dots game jam. There's a very small little GIF of you can see it playing here, but yeah, the idea is you kind of you're playing basically in somebody's PC, and there's a bunch of like viruses and stuff that you kind of need to fight off. And yeah, cool little Survivors game. And so yeah, this one also did score number 5 in the theme category with a score of 3.5 on that. So yeah, very much congratulations there for Major's PC. Okay, we'll move on to number 4. And for number 4, with an overall score of 3.673, we have Turbo Jam City, and this was by Cat and Crow Games. So we can check out the submission page on this one here, see if they have any screenshots. Oh, they don't have any screenshots, but basically the idea of this game is it was kind of like a little bit of like a city builder type vibe. And I remember there were kind of like some, cops chasing you around, and you kind of had to, convince some of the townsfolk to, help break you out of the city and stuff like that. So I think it was well done, fit the theme very well. In fact, it did get number 3 in the theme category. So yeah, well done for this submission. Yeah, this was definitely a cool one. Had a very good aesthetic and everything to it. By the way, the percentage of original art created for this game was 60%, so actually a good amount of the art was created in this one here, or during the actual jam period there. Did also score 4th overall in aesthetics. Okay, next we will move over to number 3. This one had an overall score of 3.813. This one also did score number 1 in gameplay, number 2 in aesthetics, number 2 in theme. And so yeah, we'll go ahead and check this one out. So this was Tic-Tac-No. So this was a fun one. I unfortunately got a little bit stumped on one of the levels. And really want to go back and finish them, because actually looking at some of the screenshots on this one, there's some pretty wild looking levels. Basically the idea with this one is it's kind of played on like a tic-tac-toe board. You see like this, but the idea is you don't want to get 3 in a row essentially. So yeah, it was kind of, oh wait, this actually ended up showing in a different tab. But yeah, it was kind of a challenge on one of the levels that I got stuck on because, it was a little bit of a challenge on the one that I got stuck on because it kind of had like some moving parts, and you kind of had to like figure out how things were going to move. And yeah, it was definitely challenging, but I do kind of want to go back and finish that and check out some of the other levels too, because if we go over to the actual game page on here, yeah, there's some like crazy 3D stuff going on here. So yeah, definitely would like to give that one a shot. So yeah, that was Tic-Tac-No, the overall number 3. So next we're going to move over to the number 2 overall submission. This had an overall score of a 3.962. This one also scored number 2 in aesthetics, number 3 in usage of dots, and number 3 in terms of gameplay. Actually, by the way, I'm not using OBS. This is all through an online streaming service, and yeah. So yeah, anyways, the number 2 overall is Armada, Stuck in a Naval Combat Simulator. I really liked this game a lot. Let's go ahead and go over to the game page here so we can check out some of the screenshots. Yeah, this one was super cool. Basically, you play as like a battleship, and again, kind of has a lot of these kind of bullet hell survivor type games where you're just kind of firing off all kinds of bullets at the different enemies. Thought it was really cool that there were like different types of enemies. You have like planes and ships, and the different types of weapons are more effective against the different types of enemies. You kind of have the ability to fight off some of your enemies' attacks. Like when they shoot a missile at you, you can kind of like shoot at that missile and kind of like attack them and such. But yeah, I thought this was a really cool one. And actually, I believe we can check after this, but I think pretty much all the art was created during this jam. So yeah, really impressive. I thought the game looked really cool, very aesthetically pleasing. Definitely felt like a good, complete game. Has music and sound effects and everything like that. I had a ton of fun with this. I think it was really good gameplay. Yeah, so I really enjoyed this particular entry here. So congratulations to Armada, stuck in a naval combat simulator. This one is by lucky number 8. So yeah, for your overall number 2 submission here. And yeah, it looks like 80% of the art is original. All the 3D models and textures were made, and only the sound effects and background music were obtained elsewhere. So yeah. Yeah, I really enjoyed this one. I thought it was a ton of fun. Okay, and here we are at number 1 for the number 1 overall winner, scoring an overall score of 4.250. Also scoring number 1 in terms of theme, number 1 in terms of aesthetics, number 2 in terms of gameplay, and number 2 in terms of usage of dots. Let's give a big round of applause to U0071 by Yoan. Massive congratulations. Yeah, overall, this game was, I don't even know where to start about this game. This one really surprised me. You kind of like look at the, simple little pixel graphics and you're not really sure kind of what to think of it. But this ended up actually being a quite in-depth game. I was very impressed with this. Yeah, we got awesome round of applause, in chat. Big congratulations here. Yeah, this one was super cool because basically we have all these players or non-player characters, I suppose. Let's go over to the game page here. Yeah, massive congratulations. Glad you're here to see the results shown live. So yeah, basically kind of what's going on here is you play as this guy who's kind of on this, I can't remember what the actual setting is, but it's kind of seems like almost like maybe some futuristic type space station or space base or something like that. And so yeah, basically you are kind of going around, and your whole goal is you have to kind of escape this simulation or space base or whatever exactly it is. And it was really cool. You kind of have to go up to some of these non-player characters, and you'll see that there are these little keypads, and then these people will kind of go over the keypads and they'll type in their code so they can kind of get through that door. And you can kind of spy on them, and if they catch you spying on them, then they start to get angry at you, and they'll stop typing in their code. However, you can kind of piece together their codes, and then once you have the code, then you have the ability to basically break into any door with that same level of security. And so yeah, it was really cool, and all these different people have all these individual different jobs and everything like that. So it was pretty amazing at the level of depth that it goes to. And there's also some funny little Easter eggs in here, if you walk over on the trash compactor, you basically just get completely shredded. Also, that was kind of cool, basically when you die, either going in the kind of shredded thing, or if your hunger level drops down to 0 or what have you, then it kind of has this cool little glitchy effect going on that happens. So yeah, I thought I was very impressed by this one, and I think yeah, it's well deserving of the number 1 spot for the Turbo Makes Games Dots Game Jam. So yeah, massive congratulations to this. And yeah, it would be interesting to see how much time people were able to spend. I know some people didn't have a whole lot of time. Some people might have had a good amount of time. So yeah, it would be interesting. So Yoan, I know you're the winner. You're also in here. How long did you kind of spend throughout the week? Did you spend a couple times or a couple hours a day, or were you mostly working on the couple weekends, or kind of what was your strategy for going on? And then, by the way, 99% of the art was original on this, so everything but the font basically. So that's very, very impressive here. So Yeah, and I think, just because this is the winner here, we can maybe kind of check out some of the source code over on GitHub here. But I do just kind of want to read through the usage of dots in this project because there is kind of like a little bit of an overview here. So yeah, basically, so there's room-based partitioning. So one of the goals of the project was to experiment with a room-based partitioning system. And by the way, I went all in. I think I squeezed 3 weeks into a 10-day. Lots of stuff I wanted to try for my main project. Awesome. Yeah, that's totally what these game jams are about, is you can use this time to experiment with some different things that you want to maybe try in a bigger project, and still, kind of give you that time constraint of trying to actually make something, complete and workable in a short usable time and everything like that. Actually, before I move on, I'm going to go ahead and make all the results public. Let's see where I do that. Go here. And save jam. Let me do this in a incognito window, make sure the results are live. Okay, perfect. So all the results should be live now. So yeah, if you just, here, I'll just drop the link for the direct results page. At least I'm top 20. Yeah, everyone's top 20. But yeah, once again, major congratulations to everybody who submitted a game in this. I was very impressed with all the entries here. Definitely looks like everyone kind of learned a lot and was able to implement some cool things. And yeah, it was really cool to read through everyone's kind of usage of dots and kind of like the things that they learned and everything like that. Okay, so oh, and by the way, thank you to everyone who went through and rated the games, whether you were able to participate in the game jam yourself or not. I think it really just kind of helped out, give us better results for the jam overall. So yeah, I mean, I was totally happy with this jam so far, and definitely looking forward to doing some more things like this in the future. So anyways, yeah, let's kind of dive into the winning project a little bit here, just kind of see some of the interesting usages of dots, and then maybe we can kind of dive into some things code-wise. And once again, by the way, if anyone has any suggestions for some things that they want to see me look into as far as like, code-wise goes, in either this winning project or any of the other projects that were submitted in the jam, feel free to just let me know in the comment section. And yeah, it would be really cool to know if anyone's going to be making a full game from their jam. And by the way, if anyone's catching the stream at a later date, feel free to drop it in the comments or over on our Discord or something like that. So yeah, once again, we'll just kind of go through the usage of dots in the project. So the room-based partitioning, one of the goals of the project was to experiment with a room-based partitioning system. The world is composed of rooms that are linked to each other. At the start, we scan all room entities and store their index and associated cache in a partition singleton. At the beginning of each frame, dynamic entities check if they've changed room depending on their position, and store an add, remove, or update event in a native parallel multi-hash map, with the key being the room entity, sending their entity index and cache. Okay, so that's kind of interesting. Yeah, basically each room kind of has its own index associated with it, and then we can kind of get different events for the player to do when they're kind of like entering or exiting these different rooms. And all that stuff is stored in this native parallel multi-hash map. So rooms read the hash map in parallel and update the buffer storing the room elements. In gameplay systems and jobs, it allows to query all entities of a specific room and access their cache data by only querying the target room buffer stored in the partition component of entities. Nice. Okay. So yeah, this basically seems like, yeah, one of the things that you kind of have to do with data-oriented programming is like, you kind of have to figure out how you want to kind of break up the problem. You know, when you have large numbers of dynamic entities and maybe they're doing a finite number of things, you kind of need to figure out what is kind of going to be like the most expensive and you know, kind of, yeah, the basically the most costly types of things, and figure out how you can kind of break up your problem to kind of best optimize for that. So it seems like basically, yeah, again, this is kind of structuring things in a way so that you can easily look at a room and get all the entities associated with that room. So it also has a baked flow field. So the main experiment was to create a baked flow field with, so yeah, flow field that will not be updated during game time, and referencing for each world cell which direction to take to a particular type of interest, food, work, etc. Not particularly taking advantage of dots other than being easily queried in parallel, on top of being limited for dynamic gameplay. Next step would be to use such a flow field for unfrequently updated paths while using a more dynamic updated pathfinding to complete it. So this almost kind of seems like similar to the flow field that I created for my vehicle project, which I talked about, I believe last week and in a previous episode as well. And it seems like maybe this is kind of like a multi-tiered type flow field. So like basically, you know, depending on a specific goal that a given entity has, they could kind of go into basically different parts of that flow field, and you know, it'll kind of navigate them to the correct spot, you know, in the world that they should be there. The big issue here was that food this way did not inform if the food was available or anything. That makes sense. Yeah. So yeah, basically it says, yeah, here's where the food is, but it doesn't, yeah, say that there is actually going to be food there. So you may end up in some situations where people are just kind of like waiting for food. So, but yeah, I mean, it's like, you know, one of those things where like, if you're just playing the game and you don't really have like a in-depth knowledge about what the code is and everything, then I think maybe I did see this at one point, like a little bit further into the game, where there were like a couple people waiting around for some food to spawn, but yeah, they didn't actually get it. So that's kind of funny. Okay, so deterministic gameplay. By the way, we got a spoilers tag, so you know, maybe mute it if you haven't played the game yet. So the game uses dots determinism as a game mechanic. The goal of the game is to get a series of door codes, red, blue, and yellow, and use them sequentially to get out. All codes are re-rolled the cycle every 5 minutes in a deterministic way. The player is given a level 1 basic code every cycle, but can peek when someone else enters a code. On death, we go back to cycle 1 and the simulation restarts, but all code discovers will be valid for their given cycles. Yeah, I definitely thought this was interesting. You know, thought it was cool that you could, you know, play around with like different codes. Yeah, I ended up kind of, I feel like I felt a little like this is a little bit of like a cheese, but you know, I just kind of like intentionally died to reset myself. So I was like, you know, always getting the same codes. I think for like a game jam project, this actually ends up working well, just because, you know, it's kind of like easier to do it that way almost, rather than like having to figure out all the codes within a 5-minute cycle before everything changes. So I think in terms of like gameplay for a game jam, this ended up working well. But yeah, I think for maybe like a full polished project, you know, maybe a different approach might be a little bit more appropriate. But yeah, overall, I think this was pretty cool. So yeah, anyways, we can kind of dive into some things on the GitHub here. maybe even jobified too much. Can't have too many jobs. Uh-oh. Code review time. You're on blast. Is there anything in particular, while you're here, is there anything in particular that you were kind of proud of, something that you want to show off a little bit? I know you kind of mentioned the room thing a little bit, which kind of sounds interesting. So yeah, let's just kind of dive in and see what we see here, unless there's anything specifically you want us to take a look at. So let's go into, I would assume this is probably going to be this project. We can go into scripts here. So you have it broken out by authoring, mono, system, and utilities. We do also have some kind of AI, actions, animation. Okay, so there's a lot of stuff just in the root directory here too. Let's see what we have like in terms of authoring. So AI authoring, config, corridor, depth device. All the rest are at the root struction components. Gotcha. So, yeah, let's take a look a little bit about this room stuff here. And sometimes GitHub does not like to give me syntax highlighting, which, something I feel like would be kind of nice to have. Oh, there it goes. Okay. So let's see. Yeah. So the room component, we have dimensions. We have an area authorization type. So this looks to be an enum. Okay. So this basically determines, yeah, the level, so it will be in system, room system, and room CS. Okay, cool. So yeah, this area authorization, this looks like it's kind of the different levels of codes associated with them. So that makes sense that you want to, the room should have, it's kind of authorization level, which is like the code that you need to type in to get in. So capacity is the amount of possible workers. The population is the current number of workers. The entity is a fired worker. So if the workspace is too crowded, then it will basically kick an entity out. And bool is wander path. So yeah, I'm guessing maybe wander path might be some of the kind of like intermediary kind of hallways connecting the different rooms, but that's just a guess. Okay, we also have a room buffer elements. So creating a dynamic buffer. So we have an entity, position, interactable component. So this looks to be a custom component type here. A lot of different things on here as far as interactables go. And then yes, and for entities to wander around and find a new job or else. Nice. Okay, so what else do we have here? We just kind of have some accessor properties to get some things off the interactable component, it looks like. So that's nice. So we don't have to go a level deeper. Just kind of a way to kind of clean the code up a little bit here. Let's see, what else do we got here? Just kind of looking through. Yeah, it looks like a bunch of kind of different helper methods here. We also have work info component. Yeah, let's go ahead and take a look at kind of some of the associated systems here. So the room system. Note to reader. Should we read the note to reader? Why not? This is an attempt of a room-based partitioning system. See room CS for the components in singleton. The goal is to ease detection by only iterating the elements in the same room of the inquiring process at the beginning of the frame. Objects that move or change will queue an update for the related room entities. Addition, deletion, cache update. Rooms can be queried afterwards in order to retrieve their elements. Room elements can also be modified outside of the system. And then it gives an example of action.systemcs. A lot of helpers for pathfinding and player AI actions. Nice. Yeah, I do find adding in some of those helpers in some of those components nice in some certain circumstances. It can definitely help clean things up, especially if you're kind of accessing and modifying a bunch of different things quite frequently there. Okay, so the room system updates in the fixed steps simulation system group. And so yeah, this is iSystem. We also have iSystem start stop as well. Room update type, addition, deletion, or update. And then we also have a public struct for a room update event. So we have a reference to the room element, buffer element, and the room update type. We have some component lookups. Here's the native parallel multi-hash map with a key of the entity and the value of the room update event for updates. So yeah, this is kind of what he was speaking on in the kind of theory section, where basically we kind of have all these different entities with their different room update event types, and then just kind of like, how we handle things based off of that. And so we just kind of have a query and a device query here. So looks like in onCreate, we're setting some require for updates, setting up a query here. So the query has the partition component with a position and interactable component, but does not have pickable or device tag. And then the device query has the partition component, interactable component, position components, and device tag. So yeah, we'll go ahead and initialize the native parallel multi-hash map here. Also initialize the room lookup. And then on destroy, just disposing the native parallel multi-hash map. I do also see that when you do in the on stop running, you're clearing that out. Query is for moving entities. Gotcha. Yeah, I totally get it. When you're going through a game jam, you're like, okay, what do I call this query? Like, you know what, I'll just call it query for now. And, I know what that means for now. Okay. So yeah, here's on update. So this is kind of like where most of this stuff is happening. Looks like we do have some different jobs. So here's the room update job, room device update job, partition update job, work provider job, room init job. So yeah, you definitely do have a lot of jobs going on here. So looking into the on update, so we're checking out this partition singleton. Let me see what's going on with this partition singleton here. So the partition is iComponent data. It has a native array of room data for the room cells. We have a native array of booleans for the path and an int2 for dimensions. So we have a constructor. So what happens when we dispose it? Get room data returns get room data. So this gives us room cells at index or a new room data. Is pathable. Area authorization, cell, index, yada yada. So room cells allow to know the room we're in from anywhere in the world. Nice. Okay, so yeah, we have the partition singleton, room lookup again. Oh yeah. So yeah, because you have a component lookup, so you are basically caching that at the beginning, and then you want to update that with all the latest and greatest. So count here, we do a query.calculate entity count multiplied by 2 and add in the device query calculate entity count. So map should be able to receive and add and leave event per moving entity and once per device. Okay, so basically, looks like you're kind of like figuring out what essentially the worst possible scenario could be as far as terms of number. So then you're just increasing the capacity there. Although this should update automatically, if I'm not mistaken, if you're just adding new things in here, unless there's some specific reason why you're doing that. So device is a static distributor, workstation, etc. Nice. So kind of the things that you can sort of interact with in the world. So we'll go ahead, and looks like we're just kind of doing the direct scheduling on all the jobs. So you do your room update, room device updates, partition update, room init, and work provider. So let's go through these kind of in order. So room update is first. So you're passing in the partition as well as parallel writing to this updates here. Yeah, I'm pretty sure. Yeah, I wonder if there is maybe some limitation about writing in parallel, but I thought that should know how to handle it. Because I think it basically does something like that, where if it like goes above capacity, then it just like doubles capacity, like kind of similar to how like a list works. But I should probably look into that to be sure. Okay, so inside of here, we have the room data partition.get room data. So again, we can kind of figure out some stuff about the room, based off of the position. And I suppose this is I'm not sure if this is, so room update job, does this go across this iterates across all the rooms, I'm assuming, right? With the partition component, position, interactable component, or is this kind of going across devices? Seems like this is going across the rooms. But anyhow. Yes, the entity is an entity that will be partitioned, the player, the AIs. Okay, gotcha. So we're figuring out, some stuff about them here. So new room.entity is not equal to entity.null. Let's see, so update Y offset for sorting, depending on this. So it looks like we're just kind of setting some positional stuff here. If the new room entity is not equal to the partition current room, then here's where we can actually add some things to the updates list. So here we're adding the key of the new room.entity and a new room update event. So in this case, we're going to be adding the element is a new room element buffer element with entity position.value in interactable. And so this is a room update type of addition. Here's kind of where we do a deletion type, room buffer element, partition current room is equal to the new room.entity. So just kind of setting that on that partition there. And then here's where we can also check if the position is moved or the interactable state has changed. Then this is kind of where we set the room update type of update. Okay, so that's just kind of like, I guess based off of the position, it's basically setting, kind of like initializing all these initialization or the addition, deletion, and update type events here. So that's kind of like the first step of that. Again, that's all happening in parallel. So that's the room. So now we'll go to the room device update job. So room device update job. Looks like it basically also takes in the partition as well as the native parallel multi-hash map as a parallel writer. Also taken in the position component, partition component, and interactable component. And yeah, this is kind of also setting, but I think this is for kind of devices specifically. So again, setting the room update types of addition and update kind of into that big hash map there. Partition update job. So partition update job iterates through everything with a room component as well as a dynamic buffer of these room element buffer elements. So yeah, it does a try get first value on the big hash map here, passing in the key of the entity, and then we get out of that the room update event and also an iterator, it looks like. I'm not sure. I'd have to look into, let's see if we can actually just pull this up in the documentation. I just want to see kind of what that iterator is representative of here. So on the collections package, so native parallel hash map. I think this parallel hash map extensions, but wait, it's not a multi-hash map, is it? Oh, it is. Okay. So native parallel multi-hash map. So try get first value. Description, outputs an iterator. Awesome. Thank you for that. So I'm not sure if this is just like, yeah. Okay, so this returns the native parallel hash map, native parallel multi-hash map iterator of type T key, of course. Yeah. I don't even know if this is used. I was just kind of curious. So yeah, I don't even see if you're using it anywhere. So yeah, I was just curious about what that is because I hadn't seen that. I used the native parallel hash map for the first time this jam and was pleasantly surprised by this method of iterating through it in the API. Okay, nice. Good, good. Glad to hear. Okay, so yeah, the partition update job. So then what we're going to do here, yeah, we try to do that, and then there's a do while loop. So basically, it looks like okay, I see. So okay. So yeah, basically what happens is because this is a multi-hash map, each key can have multiple values. So what's going on is it's just going through every value for a particular key here. And so they're doing this in a little bit of a do while loop. So this kind of ends up working nicely here. So then basically say, yeah, if the update type is a deletion, dirty population is equal to true. It also goes to the room buffer element, removes the elements in all that. For update, we do an update element. And then in the case of addition, then we can add the element there. Again, we just loop through that. And again, most likely it sounds like for, you know, if a particular player is moving from one room to another, there's going to be a deletion from the room that it's leaving from, and then an addition to the room that it is moving to. I think the iterator keeps track of where you are so that you can call try get next over and over with a ref to the iterator to get the whole set. Okay, yeah, actually that makes sense because yeah, right down here we have the no, Copilot, go away. It has the out update and a reference to the iterator. Okay, so that makes a lot of sense. And it will be up to date for the rest of the frame gameplay. Nice. Yeah, this Copilot thing, by the way, is like so annoying because I always like will highlight something and then like it just happens to be like right where my mouse is. It says this like rewrite with Copilot. And so yeah, I always like click things a bunch of times to like edit something, and it just always happens to be, or like if I do this, like it just is right there. And if I click again, it says rewrite with Copilot AI. Let's see what happens. So show me a better way to write this line of code, Mr. Copilot. It says to use iterator instead of IT. Ooh. Oh wait, you guys can't even see that. I will have to share my whole screen to show what's going on here. By the way, this is StreamYard. It's an online service. I think down in the description there's like a link or something that you can check out what it is. But here, let me share the full screen here so you can see what I'm saying. So yeah, if I highlight something like this, it pops up with this rewrite with Copilot AI, and then it does this, and it's like I always accidentally click on this when I just like do not care about this at all. So yeah, look, we got this sweet modification saying use ref iterator instead of ref IT. Wow. Okay. Enough about Copilot AI. So then, yeah, here, so this, okay, so yeah, this basically goes through, and again, I think these are iterating now on the rooms, correct, right? So basically every room, it checks kind of all the associated room events for that particular room. So if it's a dirty population, meaning that the population has changed, either it's increased or decreased, and we can go ahead and see here. So yep, this is going on in the rooms. So yeah, basically, if the room population is greater than the room capacity, then we pick an entity to fire, and then go through, we do a little recount. So if room population is 0, looks like we're gonna iterate through the buffer elements here. And then yeah, we're just kind of doing some, just basically some modifications to the room population, it looks like, and then we can fire a particular worker to reduce the room count if necessary. So that's cool here. I want to check out what's going on here with like the room buffer element, say like update element, like what is actually happening in this here. So for update element, okay, so basically all that's going on here is we have the dynamic buffer, and then we're just kind of, okay, so you're searching through the dynamic buffer, and it's smart that you're kind of like doing a little bit of a backwards search, because you feel like it's more likely that the entity is going to be at the back of the list. So, smart to do just that little optimization. That kind of just like comes with knowing how you've structured your data and how to like, best efficiently search that. So, it's not necessarily always the best solution to, kind of search through a list in this manner. However, if you kind of like know how things end up getting structured in your game, and it like makes sense that most likely things are usually like when you're updating things, it's usually going to be like the last 2 or 3 in the list. Then doing something like this is totally, a much more efficient option than like setting up some crazy, search algorithm or something like that. But yeah, basically it just looks like you're updating the dynamic buffer here. Tried caching the indexes on the entities so I don't have to iterate, but it was tricky. Yeah, it makes sense. And then plus that's, extra data that you have to always keep up to date. So yeah, I could see how it could get a little tricky there. Okay, so back in the room system here, and then I suppose the remove element and stuff is just kind of like basically the same. Yeah, you're just kind of doing a reverse search and then, yeah, doing a little remove at swap back. Cool. So I'm not saying the reverse for loop is slower. I'm just saying in general, if you're trying to like find an element of a collection, just kind of like iterating that one by one is going to be slower than, doing some other type of searching algorithm where, maybe you're kind of doing, I forget the exact term of it, but if you like, if it's like a sorted list, you can kind of, find things a little bit quicker. But again, if you know kind of the structure of your data, then it can be, you can kind of like tune how you're searching that data structure. So let's see here. So room device partition update job. Is that what we just checked out? Partition update job, yeah. So after partition update job is the room init job, which is this one here. So this iterates the room components as well as the dynamic buffer of room buffer elements. And we also have an enabled ref RW for the room init tag. So basically wait for the first partition update to run, get working devices. So set the room init value RW to false. So basically disable this component. And then, so yeah, this is just basically like an initialization step that kind of happens after the first partition update. And so basically you have your dynamic buffer of elements, you get the enumerator of it, and then you just kind of loop through those. You say element.current interactable working station flag. If that's the case, then you just add one to the room capacity. So yeah, just kind of like a little initialization step here. Yeah, the enabled ref is kind of a cool thing. So yeah, they use them a lot in the Galaxy sample, it looks like. Yeah, so if you're not familiar with the enabled ref RW, basically this gives you access to the component, but then you see what you actually end up doing here is you do a .value RW, and you can set the enabled/disabled state by just setting that value RW to true or false. I think it's cool. It works well. I do think the syntax is like a little bit weird, just kind of setting it this way because there are like other places where you use kind of value RW in sort of a different context. But overall, I think this is like a handy thing to use for setting the enabled/disabled state of components here. And then the last job that we have is this one here. So this is the work provider job. So this looks like it iterates everything with a work info component. Now a work info component has a lot of stuff on it here. Level 1 opportunity count, level 2 opportunity count, 3 opportunity count, admin opportunity count, direct references to different room entities, should level 1, 2, and 3 stop, should admin stop. Okay, so yeah, work info. So again, yeah, this is going to iterate everything with the work info. That's on this, yeah, work provider. So yeah, basically you're doing a little reset on those opportunity counts there. And then we get new room info by processing rooms. Yeah, this one's a bit special. This kind of seems like some kind of behind the scenes plumbing stuff. So basically some rooms are corridors and they cache info of surrounding working rooms so the entities passing by knows if there's work available to close. Okay. So it's almost like, yeah, you you took the words right out of my mouth. Like basically, yeah, you had mentioned earlier about how, you know, the flow field is great for like navigating to a specific position, but you don't know, like you can't always guarantee that when you get there, is there going to be a job available for you? Is there going to be food available for you? So yeah, it looks like this, yeah, this kind of work or this level opportunity stuff can kind of give the AI some different probably information about, you know, if there's something there that they can do or not. Okay, so, and I think that if we come back to the update, so yeah, those are basically all the jobs. So again, this is just kind of like figuring out all the room stuff. Where do you think a next logical step would be as far as looking at some things, maybe looking at some things kind of on the AI side, like kind of looking into some of their logic about kind of determining what's going on and everything like that? I mean, I suppose AI system probably seems like does this seem like a good kind of logical next step here? Because yeah, it looks like this updates in the fixed step simulation system group after the room system and before the action system here. Perfect. And yeah, AI system will use a lot of the stuff in here, so it seems like a good logical next step here. Okay, so this is the AI controller system. Bunch of different buffer lookups, component lookups, entity query. By the way, I'm 99% sure about this, and we can probably confirm with Danny when he's on next. But I think basically, if even inside, like, because yeah, the way that you're doing all these component lookups is you basically have these as like private fields for the system, kind of like associated with the system. In on create, you do your kind of initialization by doing, you know, state.get component lookup of this type, setting whether it's read only and all that, and then in your on update, then you have to do that step of doing the room lookup.update. So you kind of have to like 3 kind of like initialization steps. So basically, it's my understanding that if you use the system API.get component lookup and get buffer lookup just within your on update here, all these 3 things are generated for you in the code generation. So basically, if you say, you know, system API dot get lookup, interactable lookup, basically it will take care of creating this component lookup associated with the system, initializing it here, and updating it every frame. And yeah, if you're referring to the GitHub for this code that we're looking at, yeah, this is basically the code from the winning game of the game jam here. And I can go ahead and share this link and code if y'all want to explore or follow along. So don't remember exactly, but I recently got a warning saying, hey, you should cache the lookup. I don't remember the specifics. Okay, so I think that is, I don't think that's if you're using system API. I think that's if you're doing this, doing the state.get component lookup in your on update. So yeah, I believe if you use the system API.get component lookup, then it generates all this stuff for you. If they're equivalent, the component lookup inits versus the system API, that'd be awesome. Yeah. So yeah, I'm pretty sure the system API basically generates this version of the code for you. But then, yeah, if you were to do in on update doing a state.get component lookup, then that still works, but that's probably where you get the warning saying you should cache the lookup and call updated on it every frame. So yeah, maybe this should actually just, if they are the same, which again we can confirm with Danny next time he's on, maybe they should probably update that saying, hey, you should cache it or use system API, because they're basically the same thing. And again, you can probably check out the generated code to confirm if that is actually the case. But again, I'm 99% sure that that's the case. Okay, so anyhow, we have a couple jobs in here. So we have AI unit initialization job, AI action job, and AI movement job. So let's go ahead and dive into these different ones here. So the AI action job, I mean, it is the unfortunate thing is that we still have to pass all these component lookups into the iJob entities like this. Like, this is still a little bit of a mess. Would be nice if we could just use system API at this step here, and then it can kind of, basically take care of everything previous for it. But wow, it looks like you're using a couple components for this job here. So there is a lot going on in this. So again, this is the well, actually, we'll start with the AI unit initialization job, because that's probably the kind of logical place to start. Oh yeah, so this is quite a complex job. So this is definitely where a lot of this stuff is happening. We'll probably not be able to go through all of this line by line, just because there's kind of a lot going on. But I would like to kind of dive into it just to at least kind of get the gist of it. Okay, so AI movement job, AI initialization job. So yeah, again, a lot of components for these different AI units. By the way, just out of curiosity, I don't know if you either know this or you have your project open handy where you could check in the some of the debug windows, but I'm just curious about how many entities of these AI entities you can fit in a chunk, because it looks like you do have quite a bit of components on them. And I know some of your components kind of do have multiple data types in them. So I would just be curious about what the max entity count per chunk of these AI units is sitting at currently, just kind of out of curiosity if you have that available. But yeah, so this is the AI unit initialization job. And okay, sounds good. Yeah, it's one of those things where it's like, I don't know, it's difficult to like pay attention to chunk optimization all the time, especially because like, I don't know, the debug windows are okay, like the information is there, but it's like you got to work a little bit to look at it. And yeah, I totally understand that, you just keep adding components and then you get to a point where your entities have so many different components on them already. But yeah, so it looks like this is just kind of some initialization stuff. So we're setting the initialization tag. So yeah, again, you're using the enableable component, setting it to false. We have an authorization flag, utilities, get lowest authorization. So this is, I think, kind of the authorization level, maybe like associated with a given entity or petition. The unit identity, quite a bit of stuff going on here. Credits.admin card. So yeah, you have if you're an admin, then you get the admin card. Looks like each AI kind of has their own starting credits. Okay, chunk capacity is 26 for AI, so definitely quite a bit lower than the 128 max, but that's not terrible, especially considering about how many AIs do you have? Is it like, it seems to be maybe around 100 or so? like how many AIs are kind of moving around the simulation. So yeah, this one is for initialization from a collection that is computed at the beginning of the game. A little bit less than 100. Okay, makes sense. So yeah, it seems like, yeah, you're only using about 4 chunks, so that's really not that bad at all, all things considered. Okay, so yeah, this is basically setting up your credits, hunger value, the name. If you have short hair, long hair, has beard. This is like how like NFTs are made. It just goes through and like picks a bunch of random different attributes about short hair, long hair. And the game kind of has like a little bit of like that kind of NFT style, you know what I mean? I don't mean that to be an insult. I think the style is kind of cool, but I think it's funny. And it totally works. So it seems like all the different guys are kind of like randomly generated, so that's cool. So yeah, we're setting all the little attributes here, and yeah, cool. Okay, so we can look into the beast of the job here. So how long is this job? So when we basically start the work here, we're on 116, and this goes to 375. So that's about like 150 lines of code, right? Or no, 250 lines of code. So that's, yeah, a good sized job. And again, I think some people from the kind of more object-oriented programming mindset might say like, oh, this is a code smell. You shouldn't have a 250 line long method here. I think there's honestly no problem with that. I think it actually kind of makes it easier to read and understand when you're just kind of like going through things top to bottom. You definitely do get a little bit deep into some if statements here, which can be, a little bit confusing. So maybe that could be kind of cleaned up. Like, yeah, this part, we go a little bit deep into here. But yeah, other than that, like I'm not one who particularly has a problem with long methods. I think it's actually easier to read this way than kind of like breaking things up and reusing things in slightly generic and modified ways. So yeah, anyhow, let's see kind of what's going on here. So we have some AI timers. By the way, I appreciate just the simple little comments here and there for kind of some of the main things, just to kind of give you a little bit of a reference on where you are in the code and everything. So let's see here. So we have some AI timers. So the boredom value. It was a long 10-day. I'm sure. And again, like I feel like this AI system, this is like probably one of the most important parts of your game, and this is something that you're probably like constantly revisiting and adding things to as you're adding in features, changing things. So yeah, totally understand that. Yeah, again, all this was made over a 10-day period, so definitely keep that in mind. But again, I'm super impressed with what you created in this time frame. There's definitely a lot of things, and even if we go through all this stuff in the AI system, like we're still kind of just scratching the surface here. Like you have a bunch of different systems going on here, a lot of different components and authoring, and of course regular mono stuff here. So yeah, it looks like all the code path stuff is mono and some pop-ups in UI. So yeah, no, well done. Probably the biggest and most costly part of the code. Yeah, definitely makes sense. So yeah, it looks like, yeah, you have a bunch of AI timers going on here. So basically, I'm guessing this picks probably just like a more or less random value for, okay, so we have like boredom value, suspicion value, reassessment timer, reassess last frame. So yeah, it seems like there's like a lot of stuff that's kind of like timer based, which is kind of like, what you're going to end up doing if you want to have kind of like some kind of natural feeling AI where, they take some amount of time to do different jobs. You kind of have these little different timers to add in kind of like delays here and there. You have these different kind of like boredom values and suspicion values and stuff that I'm kind of assuming a lot of this stuff is kind of all calculated to, again, figure out what it should be doing next. Params that either goes up or down depending on time. Yeah, okay, makes sense. So yeah, again, basically, over time, your boredom value might increase, if you're not doing something stimulating or whatever, and all this. So just kind of, some pretty standard AI stuff where, again, maybe once this reaches some type of threshold that, it changes their activity, or maybe it makes them more likely to do one thing over another. Okay, so cycle changed. So I think the cycle change is basically every 5 minutes there's kind of that like big cycle change. So this kind of like does some things, stop interacting with the door if the cycle is changed. So that was probably like a bug fix, I'm guessing, that you had noticed at one point, where if like something weird would happen if like an AI was interacting with the door like in the midst of a cycle change, that maybe it would get stuck or something. I don't know. So let's see what else is going on here. So if you found a job, controller.opportunity flag is equal to false. They would still enter the previous cycle code. Now they start over. Okay, makes sense. So let's see. So if pushed, that value RO. So this is basically how you can, this again is kind of using those enableable components. And this is how you can basically check the enabled state of the component by saying, the component, the variable that you have dot value RO. Check the last movement input there. I'm curious, so does this, is this just for like non-player characters, and they still kind of have some type of movement input, I guess, based off of the flow field? Is that kind of how this works? Because I'm guessing the player controlled stuff is more just kind of like directly the player controlling and interacting with things. Whereas this kind of NPC movement and behavior, this is, again, taking all these things into account, and then it's kind of setting some movement input value here, I suppose. Okay, so process unit controller start. So this is just basically like a utility function. Looks like you pass 1.5 tons of things into here. If that returns true, then we return there. So if the AI action controller has a target, check if the position is in range. So yes, this is just for the AI. If they're pushed and they don't try to move anymore, it should probably be in the movement job. Fair enough. I get it. Again, game jam type thing. You can just kind of slot in code wherever it works, and if it works, move on to the next thing. You only got so much time. Okay. So reevaluate the current target. So if the position is in range, so we can check against the action controller's position and the action controller's range. We can set the start interacting to true. So I guess this is like, if one of the workers comes up to like a interactable console that they can interact with, redundant, then once they're within range of that, then they can start interacting and basically start performing that action. So you go to the action controller and do a dot start. Action controller. So what is exactly action controller? Action controller is an action controller, which is an iComponent data. So the start method basically just sets the timer to 0 and sets is resolving to true. Okay. Yes, and here is acting component will filter a bunch of jobs, which is handy. Sweet. Okay. Okay, yeah. So is acting says to true, and then yeah, it filters out on jobs. Okay, nice. So yeah, enableable components. They're very handy. Yeah, especially because yeah, you know again you only have so many entities, and like you don't want to be doing a bunch of structural changes, moving them around a bunch. So I think yeah, enableable components is a good solution for what you're doing. So let's see here. Controller can't reach timer. Adding delta time onto that. Can do your okay. So I guess yeah, this is if it gets stuck and like can't reach its destination for whatever reason. This is just kind of like yeah, a fail safe where you know, if it didn't reach it in some amount of time, then it's going to stop that action and presumably pick another action. So this is here where we're looking for different job opportunities. Okay, so yeah, and then actually we return out of here if you do have an action. Okay. Can't reach is another fail safe. They would sometimes get stuck. Yeah, that totally makes sense. So here's where we actually look for the job opportunities. So if controller.goal is equal to AI goal.workWander. So I guess, yeah, if you're wandering around looking for a job and workinfo lookup has component for the current room, here's where we can set some workinfo components as well as the opportunity flag here. Should stop here, authorization flag. Check if in a crowded workplace and fired. Okay, so yeah, basically if you're over capacity, then and you don't have a job already, then they kick you out of the room. I'm assuming that's kind of essentially what's going on there. Attempt at a rough midterm AI goal. So yeah, here's kind of some of the other things that they can do. So yeah, check your hunger ratio. If your hunger ratio is less than your AI starving ratio, then starving, go to closest eating space and buy food or hope for a meal drop. Nice. Yeah, because again, like you mentioned, you don't always know if food is available. All you know is where to go for the food. Okay, controller should reassess. So this kind of does a reassess, looks at some things on the hunger ratio, if it should eat, how many credits it has, class credit ratio, contamination level, work weight. Spoiler, they don't always get one. That's the simulation, you know. The food is in a limited quantity. You gotta fight for your food. I think that was how I died in one of the times that I played the game, that I ran out of food and didn't have enough food because there were like a bunch of people waiting for food and they would just like immediately pick it up before I had a chance to. So that was fun. Otherwise, yeah, look for a new target. So yeah, different things: flee, eat, work, destroy, and process. This is quite the ternary operator here. Holy cow. Wow. This is awesome. This is essentially just like a giant if-else statement packed into a ternary operator. So yeah, I mean, hey, if it works, it works. I've definitely done some deep ternary operators, but this one takes the cake. This is impressive. Yeah, whoa is right. Just let that sit on screen for a sec there. So yeah, what else do we have? Admin cleaning is admin, work goal, destroy goal. All this part is kind of heavy / hard to read, but basically the AI will decide what to do depending on the goal and stuff, then check for elements of its room and pick its target. Yeah, it makes sense. But yeah, just a lot going on in a little bit of space, and it's like I'm sure it works fine, but as someone who doesn't have a ton of knowledge on this code base, yeah, it's just kind of funny to see something like that. But yeah, no, I've definitely done things like this where I know what's going on, and it may not look the best, but hey, it works. Let's see. Here's some cleaning stuff. So this is kind of has some stuff to do with some of the admin stuff. I'm not sure if I am too familiar with the whole admin stuff in the game. I'm assuming that's just kind of like another level of another like access level, basically. I think that's kind of what I've been gathering so far. Carry item, utilities, carry item. So yeah, just again, kind of some regular AI stuff here. Yeah, again, checking some things on the hunger, opportunistic eating. So admins are the guys in white. They're the only ones know the color codes and they behave differently. Okay, cool. So yeah, you kind of have separate ones. I think that is maybe a line where I might separate that into a different job. And again, I'm not like trying to pick on your code too much because I know, you again made this in a few days and there's probably a good amount of overlap between what they do. But yeah, if they do kind of have some special unique behavior, I think that might be a candidate for, separating them out into a different job struct to kind of handle their specific logic. Or maybe you could even kind of take the approach of breaking this up into 3 different things where you kind of have like one job that applies to regular AI as well as admins, a second job that only applies to regular AI, and then a third job that only applies to the admins there. So again, I think your approach, it seems to work completely fine for this jam project. But I'm just thinking kind of longer term, that's maybe a decision I would start wanting to make there. Would have liked to have splitting more AI admin player, generic together, and then more specialized jobs. Yeah, definitely makes sense. So let's see, checking out carrying items. Here's where we're kind of doing some looking for targets. Here's where we kind of go a little bit deep into some things here. So again, we have these elements, which I think is a dynamic buffer. Oh yeah, we have it. See this right here, dynamic buffer of room buffer elements. So we get the room buffer element lookup, so we can look up the current room and get the room buffer elements on there. And then we just kind of iterate through these here, check some things on the target, action flag, door component is on code side. Okay, so yeah, there's 2 different sides on the door. So basically there's the side that you're on where you type in the keypad, and then you have to type in the correct keypad to walk in. Otherwise, if you're on the other side, I think you could just walk out the door and you don't have to like, type in a code or anything like that. So this is kind of like, I guess, where it checks the particular side it's on and everything. And then I suppose, yeah, if you need to enter the code, this is kind of where that happens a little bit here. Here's a very deep if statement where we're checking for a lot of different things here. Nothing's really particularly like jumping out to me in there, but yeah, again, just checking some very specific conditions, it looks like, in here. Not gonna lie, having them properly use the damn doors and codepads was a challenge. Come on, type in the code. Type in the code. No, it's kind of like a little bit of an interesting problem to solve, but it seems like you got it working well in the end. Yeah, again, I do think it's a really cool mechanic how they're like kind of typing in the code and you can kind of like spy on them, and like depending on what digit they're typing in, like you can see different portions of the code. It's a cool mechanic. I like it. I think it's nice and creative. And then yeah, some other stuff here. We have some teleport flags. So I guess, do certain AIs kind of have the ability to sort of teleport in some certain cases, or is there like a teleportation thing, interactable thing that I might have missed at some point? Curious what the teleportation is kind of referring to. Let's see, and then also some other actions that it can take. Again, checking some things that are in range. And has item. Okay, nice. Yeah, so again, a lot of stuff going on, but this is kind of like this is kind of like, what classic AI stuff is just kind of, a lot of values, a lot of if-else statements, doing conditional checking, and, again, checking for a lot of very specific conditions, like this, and, like this here, for them to kind of like take some specific actions. So let's see, teleport flag is for a device that teleports an item. Potato in a hopper goes somewhere else. Had to do some particular cases for. Okay, nice, gotcha. But yeah, so I mean, this is a good kind of classic AI setup. Again, it feels kind of natural, like when you're playing around, like it really does feel like all the NPCs kind of have some like specific jobs that they're like trying to accomplish, and they seem pretty natural. So I think, again, job well done on that. Was really impressed with it. Unless we can check the AI movement jobs, I think this is kind of where you start maybe keying into the flow field a little bit. So yeah, we have a flow field collection. So let's see what's up with this flow field collection here. So this flow field collection is an iComponent data. Job well done. Good pun. Got me. It started small, then became enormous. I think Thursday was full debug and spaghetti code all day. Nice. Well, hey, I mean, Thursday is a good day for debugging because you still have a couple days left to kind of close things out here. Okay, flow field collection. So I think this is one of the things that I kind of hypothesized earlier, is that you sort of have different levels of the flow field. So you have flow field level 1, 2, and 3. So a flow field, I'm guessing, is that also in this here? Okay, so a flow field, okay, so yeah, the flow field collection You have 4 different flow fields. And then yeah, you can get the direction by passing in an enum, it looks like, and your particular goal and the position. Okay, so maybe this actually goes a little bit deeper than I thought. So we have 4 different flow fields here. Each flow field has an array of cells and int2 of dimensions, and then a flow field cell. So what is going on with flow field cell? Flow field cell was up here, right? Okay, so, okay, so yeah, this is interesting. So each flow field cell has 5 different float 2s of where to go to food, work, destroy, process, or wander. Okay, so yeah, this goes pretty deep here. So they all use their own flow field. This is how the low guys will never go through a higher level door. Yeah, that's really great. So yeah, basically, again, if this doesn't make sense, so we have the whole world, right? Within the world, we have a total of 4 different levels of flow fields, essentially. And again, each of these levels kind of are associated with the type of NPC they are. So if they're a level 1, they can only get into, certain areas. They can only go through certain doors. Level 2, they have a little bit more options. Level 3, they have even more options. And then the admins, they basically have access to everything, I kind of assume there. So that's just kind of like, sorry, there's a fly being really loud in my room. So yeah, basically we have the 4 different flow fields, and then within each flow field we have a collection of these flow field cells, and each of these flow field cells has a total of 5 different values that you can essentially key into depending on if you're going to food, work, destroy something, process something, or just wander around. So yeah, this is really cool here. This goes pretty deep, and again, it gives you a lot of options to, again, get that really like kind of natural feeling behavior, because all the different AIs, they're going to have different jobs, different priorities, different places they can go. So this is really, I think, one of the main things that goes into making this world feel alive, is like having this deep flow field. Because I mean, you figure you have 4 flow fields multiplied by 5 different things that they could be doing. So you essentially have like 20 different flow fields within your world happening at once. And again, that going across around 100 different NPCs, that gives a lot of variety. So you're not going to have like, a line of like 70 entities, like literally just following the exact same path on the flow field. Like they actually like are doing different things, and yeah, so this is really cool. So what else is going on in this flow field here? So you have your dimensions, you have a native array of flow field cells, flow field builder cell, flow field builder. And again, you're kind of like caching all this stuff. So you just kind of generate the flow field one time. So even the 20 flow fields one time, so that, yeah, you don't have to like be constantly recalculating all those things. Although you did mention kind of in the theory section that you might want to add in a little bit more dynamic stuff in a more fully featured project, which could be cool. So yeah, good amount of stuff with the flow field going on here. Seems like a pretty standard flow field setup. Of course, again, with having 20 different flow fields, which I do think is quite cool. So yeah, checking into the movement stuff here. So basically, yeah, you have a movement component, AI controller, position component, action controller, authorization component here. they wouldn't have to be updated every frame, but it would make everything much easier. Yeah, I totally agree. And, especially, if you have 20 of these and, you can kind of even update them one at a time kind of thing too. You don't have to like update all 20 of them on the, exact same frame and have like a big lag spike kind of out of nowhere. So yeah, go check out what's going on here. So movement dot is running. Okay, so yeah, it looks like the movement component, they kind of have the ability to actually run. I want to check out this movement component real quick, just see what you got on here. So you have your input, basically kind of, I'm assuming the direction of movement they should be traveling. Your speed is running as well as free movement. So, action controller is resolving and action controller has target. So go to target. So it gets the direction by doing action controller dot position minus the position dot value. Then you can get your movement input just by doing kind of some standard vector math, it looks like here. If the action controller is not resolving and controller is pathing, then the movement input, so you check your flow fluid collection and do a .get direction. Here's where you pass in your authorization flag, so level 1, 2, 3 or admin, as well as your goal. So that's I'm guessing that's kind of like the goal of what the NPC is trying to do, whether they're trying to get food, just wander around, work, what have you, as well as their current position. And then, yeah, if you get a 0 back, then the is pathing is false, and then you've arrived at your destination there. And you also have your controller last movement input. I'm assuming that you're just kind of using that to like check the direction of things or something at some point. So yeah, I mean, pretty basic AI movement. Yeah, here you're basically just kind of setting your input again based off of essentially the flow field is kind of what it seems to be for the main part there. All right, well, cool. All right, well, this has been fun. I think I'm probably gonna leave it there for now. Once again, congratulations, Yoan, for winning the TurboMax Games Dots Game Jam 01. I think you had a really great submission, and really glad that you were here to help kind of walk us through some of the portions of the code. You definitely did some interesting things in here, and it sounds like you learned some things that you wanted to try out for some of your kind of more main projects. So yeah, really cool. Hope you learned a lot about all the new things that you implemented here. And yeah, once again, congratulations to everyone else who submitted a game in the Dots Game Jam. Thought this was a ton of fun. And yeah, definitely would like to have some more information on another community challenge or game jam or something like that within the near future here. So let's go ahead and go to the dynamic allocation of the week, some fun things to share with the community. I had something that was like really dumb and funny, and I don't know if I can remember what it is off the top of my head right now, unfortunately. Give me like 3 seconds. Let me see if it can come to me. Maybe we'll leave that for next time. But here's what I can do. I can do this here. Some of you may have heard of this individual here. So this is, where are we going here? Oh, it's got to be on a Microsoft Edge tab. That's fine. Okay, so this is Louis Rossmann. He is has been a YouTube creator for quite a long time. He kind of started off doing some things more along the lines of like motherboard repair, like specifically like MacBook repair, where he was like, you know, literally like soldering things together, like to fix things on his MacBook. And he kind of ran like a essentially a repair shop in New York City. Now a lot of his content kind of more revolves around kind of modern companies these days, and like how they do a lot of kind of like scummy things to, you know, just basically kind of screw over the end consumer. And he's kind of like been doing this for a while, and he presents it in a really you know, fun and entertaining way, which still kind of like brings up a lot of like kind of important issues about you know, just kind of things that I think that people should kind of be aware of in the modern day. So yeah, just want to give a shout out to Louis Rossmann. I'll go ahead and post his channel in the chat there. Yeah, would definitely recommend going through some of his videos if you find them interesting at all. So yeah, anyways, with that, we can kind of go ahead and close out our show. By the way, I do just want to mention that you still can support us over on Patreon as well as through YouTube memberships. I did last week put out a video to all Patreon and YouTube supporters, which is basically just kind of like a review of all the ECS packages. So I just kind of went, or all the DOS packages, I should say. Basically just went through, you know, entities graphics, physics, netcode, everything like that. And just kind of like talked a little bit about, you know, the things that I liked about them, some of the things that I don't like about them, and just kind of what I think the future holds for them. So that was pretty cool. Also, I have a video that I just need to post, which is I kind of did like a little bit of like a cooking show, kind of for like the supporters at the behind the scenes level. Yeah, I thought there was yeah, you'll see if you're kind of interested in that. It kind of was a fun little off the wall type thing, kind of again for the supporters and everything. And then yeah, real quick, I do just want to thank the supporters at the CPU register tier, which is our highest tier. So thank you very much to eCool for your support over there. We really do appreciate it. So yeah, anyways, with that, we're gonna go ahead and close out today's show. Hope you all enjoyed it, and yeah, we'll see you next week for another episode of the Hot Bath Show. Take care, everybody.